This example of finding coding or logical errors is similar to the format that will be presented on your midterm exam. In this case, for a significant chunk of code like we have here, I have included lines, and what you should do is you should go through and compare what I have on the lines with what the choices are. I will also tell you the exact number of correct answers. So in this case, there are exactly 14 correct answers, and the question you'll have on the exam will be similar. By practicing this problem, you'll get an idea of what the issues are. So my approach to this kind of problem would be that I would look one by one and see what the line is and if that's actually an issue or not. If it's wrong, then it's not an issue. First one is at line 5, the template should be template class T, not template T. So we look at line 5 and we see that this is an incorrect answer. So A is one of our choices. Let's look at B. B says at line 10, node star next should not be templated. This is not correct. 10 is a valid code. You need to template it like this because you have to say what the node pointer's template should be. Let's look at C. At line 14, the node's default constructor has ineffective memory allocation since the memory initialization list is out of order. So let's look at line 14. Next and data, and we see that the original order is data next. So that is a valid answer. D, the node default constructor requires brackets in order to perform the memory allocation procedure. So we look at line 14, and we see that I'm missing those. We need those. So that is also a correct answer. At line 20, the class violates the rule 3 because there's a private pointer member and the class does not define a destructor. So we look at line 20, we see that at line 16 there actually is a destructor. We see that there's an assignment operator, but if we take a look, we see that there's no copy constructor. So let's see which answer has this. So line 20, we do have a destructor. F, the class violates the rule 3, does not define a copy constructor, so F is correct. And G, it says the same thing, except does not define an assignment operator, so G is not a valid answer. At H, line 19, the set next should be const. So we go to line 29, and we see that set next modifies a private value, so that's wrong. We already see here at line 33, get next should be const because it returns a value without changing anything. So if we see here, get next should be const, I is a correct answer. So at line 37, get data method should not be const. It's kind of intuitive, a get method gets something, set method changes it, so J is not going to be const. At line 42, classes should not end with a semicolon. We've indicated that classes should always end with a semicolon. So if we look at line 42, we see it does end with a semicolon, so that is not a correct answer. L, the const ampersand in input should not be const, and 54, the int ampersand in input should be const. So those are both at line 54. At line 54, we have constant ampersand x in, int ampersand y in, int ampersand y in should be const, so this M is the correct answer. At line 56, the operator for output should have the keyword friend. We know that's the case. We see at line 56 that it doesn't. We also see that OStream does not have an ampersand output, and we don't return out the way that we should. We see that standard OStream here is correctly defined. We also see that const example also needs to have an ampersand. So these are the fixes we're going to need to make between lines 56 and 60. So we go back down here. This should have the keyword friend. 56, the precondition OStream should be called by reference. That is correct. We have identified that as a problem. At 56, the standard OStream should not be returned by reference. That's not true because it should be returned by reference. At line 56, the precondition const example, print example should not be const. We know that's false. At line 56, the precondition const example, print example should be called by reference. We know that's true, so R is correct. At line 60, the operator should return out. That is correct. We do want to do that. At line 62, the class should end with a semicolon. We know that all classes should end with a semicolon, so if we look at line 62, we see that a class ends without a semicolon, so that is a correct answer. At line 68, the line cur_node get data should actually be cur_node.getData. And then we see at line 69, the line cur_node.getNext should actually be cur_arrow_getNext. So let's take a look at line 68 and 69, what's going on there. So here we pass a pointer, which means we have to dereference it, and we dereference it with the arrow, so it's a minus and greater than sign. So line 68 is correct, and line 69 is wrong. So now we have to see what line 69 is, so V is a choice. Next, we look at W, X, and Y. Lines 85 through 87 should not have ampersand in front of the node. So let's take a look at what's going on here, and that's going to be in our main function. So we see that we have created all these values, and we pass the address. We saw that setNext is a pointer. So we have to pass ampersand in order to pass the address, the base address of the node. So therefore, we're going to see here that W is wrong. 89 should have an ampersand in front of it since print nodes passes the node by reference. So if we look at print nodes, we see print nodes is a pointer, and we need to pass the address for that to work. So 89 is bad code. The last thing we notice is we went over this example in class, but this is something you should now be able to recognize. We declared the nodes 80 through 83, and then in the node destructor, we see that I delete next. So when I connect them, I delete all of them. We kind of forgot to tell the operating system that 2, 3, and 4 still need to be deleted. So it's going to try to call all the destructors for node again, which means we are going to get a memory map, which means the destructor at line 17 deletes next, but the nodes created in main abstractly call the node destructors, leading to a double free error and memory map trace. So therefore, the correct answer is A, C, D, F, I, M, N, O, R, S, T, V, X, and Y.